Welcome to Study Loop.
For this question, we're asked to reference figure E1.28, and we're supposed to use drawings to figure out the vector sum for A plus B for part A, and the vector difference of A minus B for part B, and then using those answers, find the magnitude and direction of minus A minus B for C and B minus A for part D. Okay, so we're going to start out with just writing down the magnitude of vector A and vector B here, which doesn't include direction. But for part A and B, we're going to draw images here, right? So first, let's just start off by simply drawing the X and Y axis. Okay. Now I'm going to use red to draw our vectors that we're summing together. So the first one here, let's go ahead and write it up top. This one is for A vector plus B vector. And we're using that figure given in the question to reference these, and we're adding them together. So first we have vector A. Vector A is 8 meters, and it is straight down on the y-axis. So there's vector A. If you look at the diagram, vector B makes an angle of 30 degrees away from the y-axis, and it's going to come straight out from vector A if we're adding them vectorially. So it kind of goes up like this. There's vector B. And it makes an angle here of 30 degrees. Now, what we want to find is the resulting vector from this sum, which would be right there, and that's vector R, as well as the angle here that it makes theta with that x-axis. So we want to figure out the angle with the x-axis. Okay, so in order to do this, we're going to use some trickery here. I'm going to use some green dashed lines here to kind of draw it down. So you have a couple of right angles that get made. There's a right angle there, and then there's also a right angle over here. So what you'll realize is that the Rx value, so the value of R, the vector R projected on the x-axis, is the same as B at x, because what we want to try to find is that magnitude R. And I'll just draw it over to the side so we can kind of see what I'm talking about here. So you have this magnitude R that we're trying to find. But R must have some kind of x component and some kind of y component, right? So if you can, this would be R of y, and this would be R of x. So if you can find R of y and R of x, you can find R using Pythagorean theorem, and you can also find theta, right? Okay, so we're going to use those right angles that I drew over here to find R of y and R of x. So again, like I said, the first thing we're going to notice is that R of x is equal to B of x. So the projection of R on the x-axis is going to be the exact same as the projection of B on the x-axis because there's no x value of A, right? The y value of R is going to have components of B value of or y value of B and y value of A because they both have y values, but A is only on the y-axis. So R of x is going to be equal to B of x. And using our trigonometric identities, B of x, you'll see that it makes a larger right angle. Here, let's draw, I guess just not to confuse, let's draw this one in blue. You see this right angle here that B makes, if you could follow that green line all the way down. So here's a right angle. This angle then here, theta, has to be equal to 30 minus, or 90 minus 30, so this has to be equal to 60 degrees, right? So then the B projection, or B of x projection is going to be B times the cosine of 60 degrees. So B times the cosine of 60 degrees comes out to equal 7.5 meters. So now we have R of x. Okay, well now to get R of y is going to be the B value of y, right? Because that would be this the entire right side of that blue dash green dotted line that that's made from the B right triangle. So it's going to be the B value of y minus A of y, because A of y goes negative there. So this would be minus A of y. Well, the B value of y is B times the sine of that angle, 60 degrees, right? Minus A of y But a of y is just all of a, right? It's just going to be that 8 meters because the y, or a, is only in the y direction. Okay, so it's just going to be minus the magnitude of a, because that's all. Everything for a is in the y direction. So carrying this operation out, we find that this is equal to 4.99 meters. So now that we know r of x and r of y, we can find r magnitude from Pythagorean theorem. Let's start a new page here because we ran out of room. That's going to be r of x squared plus r of y squared. Plugging those values in, we find a magnitude of r of approximately 9 meters. Next, we needed to find that angle in the graph, the angle theta, right? Okay, well, now that we know r of x and r of y, we can just use our trigonometric identities. So the angle theta is equal to the inverse tangent of the ratio r of y to r of x. And that's because in the trigonometric identities, tangent theta is equal to opposite over adjacent. Opposite would be r of y, adjacent would be r of x. So you just have to take the inverse tangent of both sides to get theta by itself. So inverse tangent of r of y over r of x. And we find that this is equal to approximately 34 degrees. So we can box that in as our angle that's made with the x-axis. Okay, now for part B, we're asked to do the same thing, but this time we're going to use a minus b instead of a plus b. So again, referencing the same figure to see a and b, let's go ahead and draw out. Actually, let's move over a little bit. Let's draw it here. Our x and y axes. We'll draw again a and b and r in red. So you have a, then you have minus b. So there's a, there's b. Of course, b is still going to make an angle with the y-axis of 30 degrees. Well, a and b are vectors, so we need to indicate that with a vector sign. Okay, so this angle here is going to be 30 degrees. We'll just draw a little arrow indicating that it's that angle. Okay, and then that means that the vector r is going to look something like that. Okay, and then the angle theta that we're trying to find that it makes with the x-axis is going to be this angle here, that big angle there. We're going to call that theta. Okay, so now once again, we can draw some right triangles. So I'll use a blue dotted line here. So there's a right triangle here for b of x and b of y. And then you're also going to have an r right triangle that comes down here. So you can find r of x and r of y. So you're going to find this sub-angle, this one here. We're going to call this, you could call this one theta prime. And then theta is going to be 180 degrees plus that theta prime value then, right? Okay, so first thing we can notice is that, again, all of our x values are going to come from b because there's no x values from y. So r of x is going to be equal to b of x again. But this time you have to mind your right triangle, because here the value b is going to be the hypotenuse, and b of x is going to be equal to minus, because b is in the negative direction this time for the x-axis, minus the value of b times the sine of the angle 30. Not the cosine this time, it's the sine of the angle 30 degrees, because sine is opposite over hypotenuse. And so the opposite value of that angle 30 degrees would be the x value of b. So to solve for b of x, it's b times the sine of 30 degrees. So this comes out to equal negative 7.5 in the x direction. B of y is going to be equal to b of y minus a, as before. But this time b of y is in the negative direction, right? So you have negative b times the cosine of 30 for b of y minus A, which again, the magnitude is all in the y direction. So this comes out to equal negative 20.99 meters. Or we can just do negative 20.9 meters. Okay, so now that we know that, again, we can find the magnitude of R, because this is going to just be Pythagorean theorem. Oh, and above here, I have a little typo that says B of y. That's actually R of y that we just found there. Let me fix that. There we go. So according to Pythagorean theorem, this is R of x squared plus R of y squared. Plugging those values in, we find that this is equal to 22 meters. Okay, and then the angle that it makes, theta, is equal to 180 degrees plus theta prime, right? So this is equal to 180 degrees. And then again, using our trigonometric identities, that theta prime is going to be the inverse tangent of R of y over R of x. Plugging those values in, we find an angle of 250 degrees. So you can box in 250 degrees as our solution to that angle relative to the x-axis. Okay, now we're supposed to use the answers we just found for A and B to quick answer part C and D. So part C says, okay, using those answers, find negative A minus B. Okay, so we can simplify this. We'll pull the negative sign out front. That's equal to negative A plus B, right? So those are the same. It's just the negative sign isn't distributed through this time. Well, for A plus B, we knew that the magnitude of that was R. So the magnitude of a negative number is still just a positive value. So the magnitude of negative A plus B is going to be the same as the magnitude of A plus B. So that's just going to be 9.0, same as before. And then the angle here, since it's negative, it's going to be equal to 180 degrees plus the first angle that we found, because now it's going in the other direction. So we have to include that 180 degree flip that's caused by that negative sign. The negative sign inverts at 180 degrees. So it'd be 180 degrees plus the first angle we found, which was 34. So we find that this is equal to 214 degrees. And you can box that in as the solution to the angle and 9 meters in as the solution to the magnitude. Okay. And lastly, part D. Use the solutions above to find the answer to B minus A. But B minus A is equal to negative A minus B. And A minus B is what we found in part B. So we have R still, because in part B, we found the magnitude to be equal to 22 meters. The negative sign isn't going to change the magnitude of R. So the magnitude of R is still going to be equal to 22 meters. And then theta, again, that negative sign is going to flip it 180 degrees. So this flip 180 degrees is going to switch it from being negative back to positive. So we have to take 250 degrees and then subtract 180 from it. And this is equal to 70 degrees. We can box that in as our solution for the angle